Consider the functions f of x equals 3 log base invisible 10 of 2x and g of x is a half times 10 to the x over third power. Okay? Determine whether f of x and g of x are inverse functions. Well, in order to determine if things are inverses, you need to find f of g of x, make sure that's the same as g of f of x, and that they both equal x. So let's start out by doing f of g of x first. What I'm going to do is I'm going to write out all of f, but for every x I see, I leave a big parentheses there. So 3 log of 2 parentheses, and more parentheses. Now, inside those parentheses, I'm going to replace it with g of x. G of x is 1/2 times 10 to the x over third power. Now it's a matter of simplifying. Inside the parentheses, you have 2 times a half, which becomes 1. So now I have 3 log base invisible 10, so I'll write that invisible 10 out, of 10 to the x over third power. Now log base 10 of 10 to the stuff allows the 10s to cross out. So that leaves me with 3 times x over 3. With 3 times x over 3, the 3's cancel out, and we get ourselves an x. So far, f of g of x gives us x, which is what we want. Now I need to make sure that the same thing works for g of f of x. It's not always a guarantee, but chances are it's going to probably be pretty good if the 1 does work for x. So let's write out g, which is 1/2 times 10 to the big parentheses over 3. Inside those parentheses, let's plug in f of x. So f of x was 3 log base invisible 10 of 2x. Simplifying this out, the 3's cancel, and that leaves us with 1/2 times 10 to the log, and you know what? I will put base 10 of 2x. Why? Well, 10 to the log base 10 cancels each other out. The 2x drops down, so that leaves me with 1/2 times 2x. Half of 2 is 1, so half of 2x is x. So it worked for you. So f of g of x and g of f of x are the same, and they're both x. Therefore, are they inverses? Yup!